Welcome to Black Hat Windows 2K Security, held February 14th through the 15th, 2001 in Las Vegas, Nevada. The following videotape was recorded live at the conference and produced by the Sound of Knowledge Incorporated. This is videotape number 17, More Technical Track, SQL Server Security Overview.
Welcome everyone to the exciting world of Microsoft SQL Server 2000 security. My name is Chip Andrews, and I'm a developer. Feels a little like I'm in an AA meeting, the way we've been meeting developers around here the past couple of days. But we're going to talk about today is SQL Server in a couple of different angles. I want to talk about what SQL Server has become in 2000, some additions that Microsoft has made to SQL Server, how they will affect the security of the product. I'll start off with a section we just go over SQL Server security in general. We'll have a middle section where we kind of look at it from your average everyday attacker kind of thing. If you put it on the network, what are your average network hackers going to do to try to find out where they are, how to get in them, so forth and so on. And a third section where we'll talk about really SQL Server more from a developer's perspective. I don't want y'all to come here and feel like all you're getting is this stuff, everything's crap, and we can never fix anything, and we just got to wait for the latest patch. There are problems that just can't be patched, and there are things that you can do that you can take back to your developers. How many people in here are developers, by the way, application developers? There's things that you can do and things that you can take back to your developers to say, we've got this application problem, and here's what we can do about it, instead of just shutting the thing down or beating somebody over the head about it. There are things that can be done. So those are basically three areas I'm going to cover. I will start off by saying I've been a developer for about, I was a developer for about 6 years, and I kind of got burned out in development and went into consulting, and I did the security consulting thing with a large software company for several years. And got burned out on that because, well, the travel was bad. And on top of that, it was a constant negative environment where you feel like you're not really making a change. You see problems, and it gets to a point, especially with application level security, that there's always a problem, and it's just a matter of how hard you look. And you don't feel like things will ever get better until you can help participate in educating and getting with the developers to make sure that they do the right thing. And the company that I work with now, we actually created a title called a software security architect. That's somebody that's there to look at every level of application development and the security implications of things that are done building entire systems. Not just from an after-the-fact IT perspective. We'll scan it. We'll see what shows up on the on the vulnerability scanner. But from the perspective of like what David was talking about. If you look at security from looking at each level of it so that you don't end up with something like an orange where you peel back one layer and you got the pulp. But it needs to be more like the proverbial onion where you peel it and then there's another layer and you peel that and there's another layer. So let's get into it. I call the sections the good, the bad, and the ugly. There were three, and it just sounded like a really cute way to do it. SQL Server Security Overview, logins, roles, groups, users, applications. We'll just talk about the basic declarative pieces that Microsoft has put into SQL Server. The netlibs, the encryption, the integrity. In Section 2, we'll talk about, like I said again, what somebody's going to look at your computer system from outside or even from inside for that matter, what they're going to see at the network layer. What kind of, if they fire up the latest vulnerability scanner, what are they going to see, and how are they going to be able to track down your SQL servers? And in the last part, we'll talk a lot about the development, what we can do at the application layer to stop these security vulnerabilities that we've been talking about really for 2 days. SQL Server's presence has really grown. It's hard for me to go into a place now and not find it somewhere in some nook and cranny. We got, Biztalk Server 2000 requires it. It uses it for all of its storage. Commerce Server 2000 is, they're like Siamese twins. Application Center Server is a new product from Microsoft. Actually, doesn't claim to use SQL Server, but it actually uses the equivalent of MSDE to do all of its logging and so forth. And if you ever, if anybody's ever dealt with MSDE, it's a SQL Server. I mean, it's a little stripped down, but the base product is there. Third-party apps, Tumbleweed World Secure, there was a security problem way back when. I'm not going to beat them over the head about it, but they had a situation where they were shipping MSDE with their product with the no SA password. We won't have to. Hopefully, we don't have to mention that to anybody. But that's been going around for quite a while. And just some other companies. I mean, this is a short list. You can probably imagine. I don't know how many of you can just probably name 5 or 6 of them off the top of your head. Maybe applications that you have right now in your organization that actually use SQL Server. Once again, this is kind of the cheesy part where I try to get you to feel how important this all is. The assets, right? This is where you store the really good stuff in your organization. If you got a website and you're selling something, you got your credit card information in here. You've got customer information. You've got their users' passwords, authentication credentials, everything. You wouldn't believe how many times I've seen implementations where people will put not only all of this information in the SQL Server, not to say that's bad, but they use some type of symmetric encryption to protect all this, and they'll store the key in the SQL Server. So there's a place for the stuff that goes here, and there's places for other things, and it's just important to know what should go where. This is the basic, from a high-level point of view. I'm going to tell you, I got like the ugliest presentation I've seen some really good-looking PowerPoint presentations in the past couple of days, and this is my personal. I don't have a art department to come up with this stuff, so I just basically drawn out here what SQL Server does at a very high level. You've got the client who uses a selection of netlibs, IP sockets, multi-protocol, other connectivity net libraries to get through to the SQL Server in the first place. The first thing SQL Server is going to do, it's going to take a look at the sysx logins table. Who has access to the SQL Server? And that, of course, that information is stored in the master database. Outside of that, you've got another table called the sys users table. And this table is actually, there's one for every single database. So anybody that gets access to the SQL Server somehow has the capability to get in the first place, has an entry in syslogins, has to have another entry in sysusers. And that entry is what will actually allow them to assign permissions to various objects inside of the database. In which I've showed down here some of the actual objects down here, just a table, a store procedure, and then of course the syspermissions table where we'll actually decide what the user can do. All right, in SQL Server 2000, by default, TCP/IP and name pipes are enabled. We actually have that new super sockets netlib. I don't know who came up with the name, but that's how they refer to it. Allows SSL over any of the netlibs when a trusted certificate is installed on the SQL Server. Now, what I want to try to do is try to avoid going into too much detail on how to install a certificate and all that kind of stuff. This is well-documented stuff. There's a great white paper by Richard Waymeyer and Ben Thomas called Securing SQL Server 2000. If you're even going to, if you're here watching this, I assume everybody has an interest. I recommend you read this from beginning to end and then read it again. I mean, it is that good. Pardon? It's on Microsoft's site. I would have put a link up here, but it would probably be different by the time I put it up here. So if you just go to Microsoft's site and go to Microsoft.com/SQL Server, there's a place where they put all of their white papers, and it's part of that. It'll say Securing SQL Server 2000. Really great white paper. The multi-protocol RPC is no longer necessary since all the netlibs now support encryption, and multi-protocol does not support named instances. To me, that's code for soon to be retired. And I don't think the multi-protocol netlib is going to make it much longer. If any of you guys remember that in the old days when everybody would ask, and everybody posts on the news groups, how do I encrypt traffic back and forth between my IIS servers and my SQL server? And, and everything comes up. Well, you use the multi-protocol netlib because it has a little checkbox, encryption. That was the way, but now, of course, with the super sockets with SSL, you don't need this anymore. And the fact that Microsoft has, well, it might just be a restriction of RPC, but it doesn't support named instances mean without named instances, you're not going to have this netlib much longer. Of course, there's other netlibs, and to be honest, if you just look, even in books online, they're already saying that all of these protocols are supported in Windows 2000, but not for long. In the next revision of SQL Server, you're probably, I mean, sorry, I didn't mean to say Windows, but next revision of SQL Server, you're not going to see these netlibs probably anymore. You will probably just see name pipes, IP sockets. And probably, I mentioned here the shared memory, which is, they have it in there, but to be honest, it's only for connecting to the SQL Server installed on the same machine. So its usefulness is rather limited. And this new one they're calling the Virtual Interface Architecture, the SAN netlib. All right, Windows Authentication Mode. It requires the user to be authenticated by Windows NT Year 2000. If anybody of you knows that, probably back in the 6.5 days, y'all remember this was called something like integrated security, something to that effect. It's basically the same thing. What it says is, if you show up at a SQL server, I need to see a SID. And I'm going to look in sysx logins, and if I don't see your SID in there, you're out of here. So that's what that's all about. This is the new default for SQL Server, and people have been begging for this. The old default was a mixed model, which is very bad, and we'll talk about that in a second too. But now this is the default mode, so they have done something right. This is the new default way. When you just launch it and you just take all the defaults, you'll end up with Windows Authentication Mode, which means whoever has access to the machine is the only people that, NT access to the machine are the people that will have access to SQL Server, and by default that's only the local administrators group. So you will have to basically open it up to them. By default, it will be restricted to the built-in administrators group. Question?
I had installed it by default in Windows mode. I will try to get it back to mixed mode, and I have to actually do it and I have to reinstall it. Is that a caveat?
Sorry, I'm choking on water. Actually, there's a paper on that. There is a bug that Microsoft has. That people would set it for Windows Authentication Mode and switch it back to a mixed model, and it would choke on that. So they do have a fix for that, something that you can do to fix that. It's a little annoying. The other problem used to be, of course, that there wasn't a password, and people would switch it back to mixed mode just by going into the registry and flipping a little switch. And of course, now it's in mixed mode, and you may never know, right? So it only takes that one little switch. So in reality, if you go and read, especially it's in the white paper, if you're going to have Windows Authentication Mode, they recommend you go in and set an SA password anyway. It's just good practice. Good long one, complicated as heck. You know, what you would want to have as a password if the thing was completely exposed, just in case somebody switches it back. Obviously, there are restrictions. They wanted SQL Server to be one of these things that can run anywhere, kind of thing. You know, it needs to run on 98 and ME. Well, you obviously can't have Windows NT authentication on ME or 98. So they have, when you install SQL Server on any one of those platforms, you get this nice vanilla IP sockets only support, which is not the greatest. Permissions granted directly to Windows accounts, which are tracked by security identifier, which we did talk about. Mixed mode, both SQL Server and Windows Authentication Mode logins are allowed access. This is the other mode. There is no really, just SQL Server mode. This is as close as you can get. And to be honest, it's just about as bad. I mean, really, it's just saying whatever somebody shows up with, if they can authenticate one of these ways, I'll take it. Actually, the Windows authentication is tried first. If that fails, I'll accept a username and password pair. I'll compare it against an entry in sysx logins, and if I get a match, you're in. It lacks strong authentication controls. There's no password complexity. It's really a sorry security model. I mean, there's really not much you can do. You can't even tell, a minimum password length. I mean, you can't even set that. So if a person has the capability to run, SP password and set their password to the letter A, it's not a problem for SQL Server. But it's provided for backward compatibility, and Windows 98 ME installation, of course, required. Microsoft recommends that you use Windows Authentication Mode, and it sounds easy, right? And least common denominator thing, right? If you're running on NT, NT security, if you can trust NT, well, that's what we'll bind SQL Server to. And then whatever problems come out, we can always say, well, NT's got that problem too, so it's not really a problem for SQL Server. The problem is that everywhere you look, you get the mixed messages because Microsoft turns around and uses the mixed model in a lot of things they do. I don't want to say everything, but in a lot of things that they do, including Microsoft Commerce Server 2000 and Biztalk. Many developers avoid anything that involves having to learn a security model, usually reserved for IT personnel. Well, as many of you guys know, I'm not say all, there's a large group of developers out there who don't care a whole heck of a lot about what happens in the IT world. And they probably don't care a whole lot about NT security in general, because it's not cool. If you're writing the new latest and greatest XML app, and you're writing SOAP calls, and you're doing all kinds of new stuff that you just got out of a magazine, that NT security stuff is kind of boring, kind of dull. And generally, what they'll do is in the books, and you guys have seen them. If you look in there, there was some talk about it, in the magazines. Everybody uses connection strings, and everybody puts in every little demonstration app they write a username and a password in their connection string, which goes right back to this. We're right back to the mixed model username password pair that everybody's wanting to use from now until end of time. And it's all because, to me, it avoids the problem. It makes it so that we don't have to understand things like trust models, and we don't have to understand things like, for instance, using a domain user account rather than, local user account. Or, there was 1,000 things that go wrong when you try to do this, try to seduce a Windows Authentication Mode application, not understanding the Windows NT security model. Things don't work. You get up frustrated. You set it back to a connection string. You use mixed mode authentication, things work, and you go on about your way. Performance issues with connection pooling if users have their own security contexts. That's another issue that always comes up. They'll say, well, I don't want to use this Windows authentication stuff because I don't want people to be having their own context and having their own special connection, because now I can't pool their connections because they're not all the same person and I can't reuse them. It's something that comes up. There are ways around it, and we'll talk about that later. And of course, my favorite, developers love connection strings. I don't know why. It's a truism. All right, the logins. I want to kind of go through this part fairly quickly. It's kind of mundane. It's very books online-ish. I just didn't want to go by it and not mention briefly exactly how the model works. SIDs of users and groups store for Windows authentication logins. Somebody may have already been starting to wonder if you're storing SIDs and that's how you're using it. If you have a username password pair, doesn't that need a SID or something? Well, they just generate a SID basically for SQL Server logins. Users are stored in individual databases in the sys users table. Determines who has access to database objects. This is where you start to use your ACLs, right? You create a table and you want to give somebody select access to the table. Sys users is the user. That's the table that it looks to when you decide to give somebody access to it. It can be assigned to a fixed or user-defined database role. The roles are kind of an interesting thing. They are good. It's a little confusing for people because they use the same name, roles. A role is, think of the fixed roles as special roles, like roles that can do special things, whereas the user-defined database roles are just ways for you to create groups of people, basically. The fixed roles all have some special permission, like the DDL admin can issue, drop table, and your DB owner, obviously that's just your DBO. That person pretty much is God in that database. Their user privileges can be managed using grant, deny, and revoke. Simple stuff. General database administration stuff. Somewhat analogous to user rights in Windows NT 2000, the fixed server roles, sysadmins, and there's actually quite a long list of them. Like I said, in addition to those, there are fixed server roles, there are fixed database roles, and then there are user database roles. And this is basically just reiterating what's on that last slide. You have certain roles that give you extra permission, or I kind of like to think of them as like user rights. And the rest of them are just for ease of administration. And a lot of people have a question about application roles. What good is that? The application role basically came about when people wanted to create applications, especially intranet or client-server applications, where you want to give somebody access to a table so they can read some data or maybe write some data. But you only want them to be able to do it when they're in that application. You don't want them to fire up, Query Analyzer, Enterprise Manager, whatever, and start to monkey around in there, because they do have the permission. You gave it to them. And that's where the application roles really came in. What happens there is you really don't give any user access to anything if you don't want to. They don't have any rights. However, what you do is you have them, they'll still have a login, sysx login, so they'll still be able to get in. But as soon as you begin that application, you can switch that person's context. It's basically just, it's like impersonation. You just turn on and say, okay, stop being this guy and be this guy for the purposes of the application until this connection ends. SQL Server 2000 now has C2 Style Auditing. I assume this was done to meet the C2 level of security. They're now C2 certified. This was probably something that came up because of that. If you've ever dealt with SQL Server logging up to this point, it's pretty weak. So, this was a have to do probably to meet those requirements. What it really does is if you turn this on, you'll get this file, this trace file basically, just logs everything, and I mean everything that occurs on the SQL Server. I think I ran this for a day one time. This was just on it was on a development box, and I ran it for 6 hours, and it was, I think it got up to like 570 megabytes or something to that effect. Not something you want to leave on for too long. If you got the space, you can do C2 Style Auditing. XML support. With SQL Server 2000, users can return data and create queries using XML. I want to apologize, first of all, you probably don't have this slide in your book. I do have some bonus tracks that I developed between the time I sent in the preview and sent this in. So if any of you guys want this updated one, just let me know after. But basically with the XML support, you can return data and create queries using XML. It's pretty straightforward. They give you about 4 ways to do this. And one of the first ones is URL queries. And I don't know who thought that was a good idea, but apparently it was, I could imagine it was there to help developers or help people play with it. But at the very least, what you can really do is once you set up a virtual IIS server to use the ISAPI filter for SQL Server, you can actually issue your queries right there at the command line. So you can just, pull up your web server and then, SQL equals blah, 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 and hit return, and your data set's returned right there in XML. It's cool to play with, but that's just as good as giving somebody direct access to the SQL Server with Query Analyzer and saying go to town. It's not controlled access, and really what I'm saying here is the two ways you probably want to, if you're going to play with this at all, try to stay within the template queries and XPath queries, because that way you can at least control your access. I would never leave that URL queries or post queries on. All right, a recap of some other SQL Server 2000 goodies. Multiple instancing. We'll go more into that a little bit later, but you guys know what that is, right? You can install multiple SQL Server 2000s basically on the same machine. So you can really have, if you wanted to, 5 or 6 different instances of SQL Server running simultaneously. The advantages of this, some people always say, what the world do you want that for? Well, I can imagine situations where you're an ISP maybe, and people don't necessarily want to be sharing their space with others. Sys login space, for example. You want to make it look like that person has their own SQL server, and there's really nothing else going on. Nobody else is playing in there, and it's good for that. It's also good for testing. There's a new variant data type. We'll talk some more about that later. Crypto API is now used for all internal encryption. That Microsoft used to have some type of proprietary encryption scheme they used for basically encrypting things like passwords and sysx logins. There were all kinds of little nooks and crannies where they would try to encrypt things, and apparently this is Crypto API is what they were using for all of that. XML raises some old issues in a nice, well-formed way. That's an XML joke, man. Nobody gets it. Delegation now supported for SQL Server. Now, it's only supported for SQL Server 2000 when you're installed on Windows 2000 and when you're using Active Directory. So a few requirements there. Basically, the idea with delegation, of course, being that you can hop with your same level of context from one machine to another, unfettered. You don't have these same kind of problems that you used to have with impersonation where, well, you could impersonate this account and then you could make like a one hop to a SQL server, but then you couldn't impersonate again if you had to go off to another machine. User-defined functions, something new in SQL Server 2000, probably because people were whining because other database systems have been supporting them for years. And cascading referential integrity, I only mention it because it does raise some interesting issues. There was an issue yesterday where somebody was dropping a table, in SQL Server where they had passed through some SQL. And you can imagine a situation where somebody goes, instead of dropping the table, was just delete all the rows from the table, where there was some referential integrity going on, so that if you had cascading deletes, and I deleted all of the orders, all of the line items and everything else that's attached to that order would go with it. So with a single command, you wouldn't only be necessary, you couldn't only knock out a single table, you could wipe out somebody's entire database with a single command. Microsoft has made some great strides to improve the security of SQL Server. Some ideas for future releases, these are ramblings, my own personal things. The field level encryption, they're using Crypto API now. They probably feel a little more comfortable with their encryption, so it would be nice if somebody would have the option to do it inside of SQL Server, only because everybody seems to ask for it. And of course, the answer everybody gets is, well, you don't really encrypt stuff inside of SQL Server. You encrypt it with some COM component that you wrote somewhere else, and you just put the information encrypted into SQL Server. That's SQL Server. That's Microsoft's way of getting around the problem. Maybe if you just included it, the questions would stop rolling in. Doing a better job of leading by example when it comes to recommending security models. And consider disabling the use of the local system account for the Microsoft SQL Server service since certificates are not supported. Like I say, if you run the SQL Server service as local system, certificates are not supported. So why is it there now? It's obvious that it's one of those things that's kind of on the periphery to be sent to the scrap heap. I don't know how many of you actually have installed SQL Server 2000. Yeah, you've noticed that you now have the option, when it gets to that page, the default is really sitting there for you to put in a user account. But right above it, lurking, right there, local system. And about 70% of the time, I've noticed that people just punt because nobody's gone and created that account yet. They don't want to have to go through the trouble. It's a pain. You click local system, boom, everything works. Except when they want to start doing, SSL with certificates. All right. Section 2. So now we're going to get to the fun stuff. I'm going to let the boring. Yeah, sure.
Are you going to talk about the minimum rights that the account has to have for SQL Server to work correctly?
Well, here's one of the beautiful things. Microsoft has been kind enough in that same book, that same document I talked about, to list those explicitly. I didn't want to just regurgitate what's in those documents. In that same document, Richard Waymeyer and Ben actually explain exactly what rights you need for those accounts. And here's the beautiful part. As long as you make those changes within the Enterprise Manager, with the tools that they've provided, they'll make those changes for you. So if you start going out and just go to Control Panel Services and you start mucking around in there, and then you go in and change it there, you're going to have problems because it's not aware that that user needs to also have these other rights. And if you just kind of go with the flow, use the Enterprise Manager, the MMC plugin, and just make the service account change there, you'll be rewarded for it. All right, we're going to talk about it really from a network security point of view. Fingerprinting and discovery of SQL servers, acquiring access, privilege escalation, potential pitfalls. This is a really nasty area. This is kind of one of those things that you probably hear a lot about. You might even be able to find some of this on the internet. I was very frustrated when I started programming with SQL Server about 5 years ago that I couldn't find any resource on SQL Server security. It was non-existent. I went to the security websites, and every now and again I'd find a little reference to a null SA account or something like that. But there really wasn't anything out there. So that's where I created a website for doing that, SQLsecurity.com. And I just started posting all the stuff that I could find on the site. And a lot of what's in this section is on the site. I haven't really devoted like a section 3 where I'm talking about, SQL injection and input validation and things like that. Haven't really put that on the site yet just because, I got a job and didn't get around to it, but I will eventually post this stuff up there. Target acquisition. Well, if you look at somebody that's got a commerce website and they've got IIS, chances are there's probably a SQL server back there somewhere. I don't know of too many people that use IIS on their web servers and Oracle on their back end. It could happen, but usually somebody that's Oracle savvy is not going to have much to do with IIS. Obviously, telnetting to the server, doing the head directive. Heck, go to Netcraft if you don't want to know it was you. Pretty easy to find out what somebody's web server is. You can also dig around for hints about the target database usage. You go to the news groups. The people that are working there are probably posting about all kinds of problems they're having. They'll probably tell you what they have there. Go to the discussion boards. Corporate website, that's a great one to me. You go to the target's website and you go to careers and they're hiring a SQL Server DBA. I wonder what they're using over there. Some people are pretty free with the information, so it's not that hard to find out what somebody's using if you really want to. You go to Monster, obviously, there's a lot of ways to find this stuff. Good news, most developers need help somewhere along the way. News groups are great for that. Bad news, you may be announcing your architecture to potential hackers. And here's a little sample search if you just wanted to find out, if somebody at that company is having some kind of SQL Server problem. The normal way people are going to find your SQL servers, of course, they're going to fire up Superscan, Mmap, whatever, and they'll just do a quick 1433 sweep your entire network. In SQL Server 2000, if you guys have noticed, there's an option, especially with when you start dealing with multiple instances, to just let it dynamically assign the port. Who's seen that dynamic port allocation in the server management? Have you seen that, server network utility management? We're going to talk about how that happens. And the way it happens is this, that UDP port 1434. If you've ever had to configure a firewall between IIS servers and a SQL server, before it was just, you open 1433 and everything's great. SQL Server 2000 has made some changes, and you really have to open up another port now, and that port is UDP port 1434. So the reason that this port has to be open is to support the multiple instancing, right? It was real easy before to, when I connect into a SQL, I know if it's 1433, that's who I'm going for. Actually, you could still change it in the older versions. You could switch it to something else. But if the client utility wasn't also configured to use the same port, you weren't going to be able to connect. SQL Server now has this new feature. It's a listener on 1434 that basically is waiting for a single UDP packet. And when he gets that packet, he's going to send back all of the wonderful information about every instance that's installed on the machine. He knows every single instance, the name of it, the protocols that are supported. If you're using IP sockets, he knows the port. He spills his guts. If you have multiple, not if it's SQL Server 2000.
Yeah, even if it's single instance, I connected one. I only have 1433 open.
Really? I've had problems with it. I've been trying to connect them through a firewall, and I actually had one. We had SQL 7. It was working fine. We obviously upgraded it to SQL Server 2000. Wouldn't connect at all. And all we did was, I had to go in. It's actually documented in books online that it's a requirement. Did you use the default instance?
I had to set it, I had to tell it to where the port was for the second instance.
Okay.
What I was able to do with the 1433.
Now, if it was a SQL Server 2000 machine that was installed on top of SQL 7, and the SQL 7 was still listening on the default 1433, but SQL Server 2000 instance was not, then it would still work. Now, here's just a simple scan. I mean, you guys have probably seen this 1,000 times. Where it's going to stick out like a sore thumb. There's a SQL Server here. All right, and here's where I talk some more about the the discovery using UDP 1434. What's interesting to me about this is that it also gives you a nice little tip-off that there's clustering support. That's a nice little thing to know. If you ever wanted to spot a juicy target, I can't think of a juicier one than some SQL Server that's clustered. All right, now there's a little switch on Osql utility called the -L switch. And if anybody's ever done it, what it does is it just lists out all the SQL servers that it finds on the network. And what it really does is it sends out a UDP packet on, it directs it at 255, 255, 255, 255. Every SQL server in listening range will reply back with one of those packets, those discovery packets we were talking about. Now, the Osql tool only returns the server names. That's not very useful. So here is what a discovery packet looks like. When you see this thing come back, you're going to see all kinds of juicy information. Now, I just used Snort to pick this up. Me and a couple of guys from work got bored one day, and we just decided we were just going to write a better one. So we wrote this SQL ping utility that does the same thing. It's not rocket science. We're talking about 20 lines of C code here. But all it does is it goes out there. It allows you to pick the target address. And, of course, anything that's listening, it's in that broadcast range. You can direct it if you don't want to broadcast it. You can say, I want a particular machine, or I want a particular network. And anybody in the listening range should reply with this information. And as you can see, there's quite a bit of information that can be divulged here. Not to mention the fact that it gives you the version number, which is real nice to know because the version number is also tied to exactly what service packs have been applied to the SQL servers. So just by looking at the version ID, you can really tell if SQL Server 7 has had X service pack applied. So it's really easy to identify vulnerable servers this way. And of course, that's why I wrote it, is to find vulnerable servers on our own networks. Brute force, mixed security model. There's a lot of tools out there. I'm not going to go into details on them. I've got most of them posted up on my site. They all pretty much do the same thing. They try to connect to the SQL Server using brute force methods, usually directed at the SA account. Why? Well, there's no lockout threshold. By default, there's no logging that takes place. You can turn it on, but who looks at SQL Server logs that you know of? Most people don't, fortunately. So I've seen people go to town for days and days and days wailing away at a SQL Server until finally success. SQL Server lacks account log. We know that. And of course, I said I was going to mention the null SA account, but I've already done it 3 times now, so I'm just going to let it continue. Don't do that, please. Sniffing, mixed or anti-security mode. Obviously, this is another way that you can try to find these ways. I'm just giving you more ways to get into the SQL Server. To be honest, if you got people listening on your network with LOphtcrack, you got bigger problems. And of course, TCP 1433 traffic. There's a lot of stuff that's going. There's a lot of data that's passing forth there. So if you think that there's something that somebody shouldn't be seeing passing across the wire, you need to start thinking about using some type of TCP/IP encryption. I'm not saying you should go with Microsoft's model with the super sockets SSL and all that mess with installing the certificate. IPsec, great option. If you're just going maybe server to server, that's probably your best bet. If it's client to server, unless you have control over every single endpoint, it might not be the best option, and maybe you should probably fall back to SQL Server's encryption. Sure, I'm sorry.
Do you know a way of fingering the mode that SQL Server is in?
Whether it's in one of those 2 modes?
Whether it's in integrated or mixed?
Not really. I don't know any way to just. Obviously, it doesn't fingerprint. You can kind of tell when you're looking at the protocol support, but you really don't know until you attempt the connection. Obviously, the first way to try is just to use Osql and just make the attempt, right? It's hard to. You really don't know until you kind of start to play that I'm aware of. I don't know of any way to just say, what mode are you in? Connection strings. These are bad. I mean, we talk about it over and over again. I think it was the other. I think Samuel and JD Glasser were showing a demonstration up there. They had the ASP page up there, and there was a connection string. They had a connection string in global ASA. You know, you got to put it somewhere. That's always the theory. I have a slightly different theory on connection strings, and the theory that I have is the connection strings themselves aren't bad as long as they don't contain secrets. If they contain secrets, they're bad, because sooner or later, one day, somebody will, you know, that new IIS vulnerability will come out, and there it'll be. There's your connection string. So when you code it, when you put it in there, just plan on somebody to be able to see it. And go ahead and try to write the connection string so that there's no secret. If that means using only trusted connections and integrated security, then that's what you do. And if that means instead of putting, you know, provider equals something something, so that people know what network provider you're using, and, you know, data source equals, and then pointing them towards the SQL Server, and, you know, use a DSN. This is the closest I come to like special effects. Yeah, buddy. That was oh, what have I done here? There it is. I've killed it. One space bar too many. What we got here is just a small sampling. I just do this to reiterate a point. When you put the strings out there, plan on people seeing them. Don't code sensitive information in script, period. I don't care if it's connection strings. It could be hard-coded, you know, it just could be, maybe your authentication routines, your cookie routines are all stored in code somewhere. You need to keep that stuff hidden. Wrap it up, comment, compile it, get it out of script, because these things will bite you every time. XP command shell. This one goes around and around and around. It's the #1 target. SQL Server 2000 is a little bit better in that it does not allow non-sysadmins to access XP command shell at all, period, by default. You got to turn it on. There is a proxy account that you can assign to have access. You can go in, it's in the Enterprise Manager, you can say, okay, everybody, if you want to access XP command shell, you can, but you're going to do it as this guy, and hopefully it's somebody with very low level of privilege. And of course, behind that, you've gone through and ACLed everything on the machine so that they can't do jack. You were just over there in the, you know, the LeBlanc demonstration, and you should know how to do that by now. The real problem is attacker can access SQL Server System Administrator that can execute the operating system commands with the security context of the MS SQL Server Service. That's if it's running as local system. Not necessarily the case, and it doesn't have to be that way. You can create a nice little domain user account and use that. SQL Server does not have these huge requirements. It requires it to be running as a local system. It's just been a convenient thing to do, and so people have done it. It doesn't have to be that way. Take the time before you install SQL Server to create an account and use that account, low-level privilege, for SQL Server at installation time. And if you do that, SQL Server will take care of those ACLs for you. Yes?
Just one quick question regarding the second bullet point there. Administrators can assign a proxy account.
Yes.
Non-sysadmins can use XP command shell. Where is that information stored at? Is there a table, or where is that information actually stored as to?
Who is the proxy account? To my knowledge, I believe it's in the registry. Is in the registry. Properly ACLed, of course. Other methods, and some more interesting things that people will always try, is the old XP reg read and reg write. They'll go in and they'll try to, by default, of course, this stuff is fairly secured. Only the SA account should have access to this stuff. The automation, very important. I mean, you can imagine if somebody's able to get in as SA, even if you've somehow, you can go in and actually drop those extended store procedures. I didn't mention that before, but you can do that. You can take XP command shell and just drop it. The real problem that I have with the dropping it is that if the person gets in as SA, they can just add it back. It's not a big deal. There's a command for that too. And if the DLL is still on the machine, it'll still work. So it's a little bit difficult. And a lot of times what I've found too is that Microsoft likes to wrap up some of the extended store procs. They like to put like 4 or 5 of them in one DLL. So you'd like to be able to just get rid of of 1 and then just rip the DLL out and get it off the machine. But unfortunately, when you do that, you break about 5 or 6 of them simultaneously. And on my site, I actually have a query that will show you, if you want to get rid of an extended store proc, it'll show you what other procs are using that same DLL. So you can fish them out. There's a ton of enumeration functions in the extended store procedure list. I didn't even bother to bring them. I mean, if you just go in, you can look at the number of extended store procedures that SQL Server has now, and the list is a long, long list. We'll come back to that too. There were some issues with some of them as well. And other methods, there was an issue a while back with the open row set. What would happen is that you would open up a query in SQL Server using SQL Server authentication and then attempt a trusted connection to another machine, or to the same machine, really. And what would happen is SQL Server would kind of punt. It was confused. It wanted to create a trusted connection, but you signed on using SQL Server authentication. So logic demands that then I revert back to the local system account and start doing stuff. And so then if you were to launch XP command shell or something like that, it would work, even if you were just a normal user account. That has since been patched, by the way. But that doesn't stop people from, once they're able to get into the SQL Server, from using that as a mechanism to, say, attack other SQL servers, right? Because you can just say, hey, I want to use a query, but instead of this one field, I want you to go out to this SQL Server and pull in some other value. Oh, and here, by the way, here's my authentication information. And if that fails, why not write a script that just goes through and brute forces their way in? As long as it's using, as long as it's using SQL Server Security, that shouldn't be a problem. All right, other potential pitfalls. System extended store procedures have been found to have buffer overflow vulnerabilities. There's a link up here. You can go there. It's at stake. Some nasty problems here, not the least of which is that most of the extended store procedures that they found had buffer overflows were executable by everyone. So really, at that point, if you had access to a SQL Server at all, you could gain Microsoft SQL Server service context. It wasn't a problem. And also, you can write your own DLLs. And anybody can tell you, if you start writing your own DLLs, you've got to be careful that you don't make the same mistakes that Microsoft did and make your DLL so that people can exploit them, because they'll try. All right, if they're in, what are they going to do? Well, they're probably going to try to create a backdoor account. Maybe they'll create another account just for accessing something in one of the tables in one of the databases that they want to come in and get periodically. They may Trojan SP password to capture passwords. I really don't see this one a whole lot because who uses SP password to change their password nowadays? And most people set a SQL Server, if they're using SQL Server Security at all, they're setting the password and they probably never change it again. Why? Well, once again, SQL Server has no such thing as a password lifetime. And you just set a password and it's happy to let you have that password from now until the end of time. Using TFTP to pull a Trojan extended store procedure in, not a problem, unless, of course, the proper ACLs are in place. And use the SQL Server to launch attacks against other hosts, which is the favorite, right? This is the one I see all the time, is once you're in and you have control of a SQL Server, it's a great launching pad. And the beauty of it is that no matter what you start to do, it looks like the SQL Server did it. So, I mean, it's really a beautiful way to tour around the back end. I mean, it's like you're immediately going into the heart of the system, where everybody's storing everything that's of importance, and no matter what you do, it looks like it was done from within. Things that you can do: intrusion detection and auditing has some usefulness. I'm not real big on it. You can create an auto start store procedure to initiate a trace. I know a lot of people are flipping, because I don't know if this slide was in there. but what happens here is, you can create your own trace, basically, to just, when somebody starts up the SQL Server, just start dumping these things. And these things are these things that you set up with SP trace set event. So you set certain events that you're interested in tapping, and you can create your own custom trace logs. they're good if somebody's looking at them, they're good. Like I said, like somebody was saying here earlier, you know, information is better than no information. So if somebody's looking at these logs and making sure that somebody's not trying to run something they shouldn't be trying to run, it's a good thing to at least try. The profiler trace can use to input records directly into an audit log, which might even be more useful, right? If you can take that information and just put it right into a SQL Server table, it's not sitting out there on a file somewhere that somebody has to audit. And you might be able to put that information into a table and then have a query run periodically. Or if you were really proactive, you may write a trigger on a table that waits for something to come into that table that it doesn't like, and then it could fire an alert off to an administrator, something like that. So in a sense, using nothing but the profiler and a little custom SQL, you could write your own SQL Server intrusion detection system. All right. This is pretty much the end of what I'll call the network hacking type section for SQL Server. You know, this is what people will be looking for if they're trying to come at your SQL Server just from a network point of view. Take the time to scan the networks. See what they can access. I mean, do it to yourself. Look for 1433. Look for SQL servers in general. Use the SQL ping tool if you have to. See if you can sniff out where they are. I don't know how many of you have to deal with developers, but I would say that in our shop, when I do a quick scan, I come up with about 95 to 98% SQL servers being installed on developer machines. And of those, another 40 to 50% probably are in mixed mode with varying levels that I won't divulge of null SA, which is sad. We are cleaning that up, by the way, and I urge everyone here to do so. You never know what people are doing, especially if you're in a natted environment where somebody's you know, connecting to the internet, maybe, heaven forbid, creating their own VPN tunnels out to somewhere else, and you know, their vulnerabilities are yours. Don't think just because it's a workstation, you know, that some developer is using, there's not important information on it. Developers have source code. Especially if you're a product company, there's no more valuable resource than your source code. You know, I just did a sweep one time, not from my house, of course. You go out, you find yourself an acoustic coupler and a payphone and a free ISP, and then you can, you know, probe around a little bit. I was just looking at my own ISP, and I found on my subnet, not, you know, 4 hosts up from mine, there was somebody that was working for a large corporation that was a developer, had his machine hooked up. It was a cable modem, and there it was, SQL Server, LSA password. It never fails, and I think that's 4 times I've mentioned it. Please don't forget it. All right, the ugly. This is the fun stuff. This is where it gets serious. There's no patch for this. And there's nothing that anybody can tell you that you can do. There's no product that you can buy that's going to fix these problems. These problems are fixed by basically enforcing best practices. And we'll discuss at the very end of this what you can do. Because I know that you don't want to come away from here thinking, well, damn, you know, everybody's been talking about all this stuff all week long, and there's really nothing that we can do about it. There are things that you can do about it, I promise. Okay, the basic problem with SQL injection. If an attacker is able to inject unintended SQL statements into an application. Now, why does this happen? The basic problem is that SQL Server accepts batch commands. If you just fire up Query Analyzer, you can just type, you know, select star from sysobjects space select star from sysusers. You just try it. What does it do? It returns 2 record sets. It doesn't know that you're just wanting one command. It thinks that it's just going to go across and parse that query. When it gets to the end of one, it sees another select statement. It says, okay, that's the end of that one, and let me just go ahead and process this one. He batches them up. That's the problem. It's the basic problem that we're dealing with here. There are others, but by and large, especially with what they were showing, you know, in the demonstration next door with Sawmill yesterday is that you just can't trust that what you write an application to do is all it's going to be capable of doing. Somebody's always going to be thinking ahead and thinking of how to break into this thing. And you need to be thinking that when you're writing this code. Obviously, some of the consequences of not checking: exposure of sensitive data, SQL privilege escalation, operating system access, heaven forbid, and COM access, maybe access to your DLLs or some other piece of business logic you may not want people to get their hands on. The scope. SQL injection attacks rarely alert IDS systems, especially over SSL. What IDS system looks for somebody to type in some SQL code in a form field? I haven't seen one. May exist. Somebody might be working on it. I haven't seen it in a while. To be honest, you can pretty much play all day long with SQL injection attacks, and probably nobody will be the wiser. Maybe you might get caught if you were doing a lot of it and somebody was doing some of that C2 level auditing we were talking about, right? So they're watching maybe every single call that's going back to the SQL Server, and then they see somebody chaining two commands together. Now, how they're going to know out of a 500, how many did I say, 570-something megabyte file, that they're going to be able to find that one or two entries that had two commands on them? Good luck. But basically, what you got to look at here is that your IDS systems are pretty useless when it comes to this stuff, not to mention the fact that you got SSL on top of that. We already know the problems that causes for your IDSs. It's difficult to track down all the areas of exploitation. Manual code review is really the best way. I haven't seen a really good automated tool for testing. I don't know if any of you have heard of any for testing for these types of vulnerabilities. I know that there's a company called Sanctum Inc. that has something, it's fairly close to this. They're trying to get there. But I've actually seen the tool, and at this point I would say it still doesn't have any real SQL injection testing capability. It's more things like cross-site scripting, just cookie poisoning, things like that it checks for. No amount of OS security firewalls and patch diligence will stop SQL injection. It's a truism. I can't think of any better way to say it. You're just going to have to get with your developers and find ways to fix these problems before they show up, period. All right, here's the sample crappy ASP code that you find in every damn magazine telling you how to access something. I mean, it's just awful. This is so bad on several different levels. Con open, right? And here's my DSN. And actually here, I've actually improved it a little bit by just saying DSN equal and not saying provider equals, data source equals, and exposing where my SQL server is and exactly what I'm using to connect to it and all that kind of stuff. Still crappy. And here's the password for you. And of course, the unchecked, unvalidated input from the browser. Some people, I've had developers argue with me forever. Well, we don't have to worry about this on the server. I've got JavaScript that I check to make sure that this stuff is good. Yeah, right. I mean, it doesn't take a genius to figure out, once somebody gets the code on their machine, it's client-side code. It can't be trusted. So input validation, you have to do it at the server. Doesn't mean you can't still do it at the client. The client might be more efficient. If you're going to check for, somebody to enter a field, you may not want to have to make that round trip that, oh, geez, they forgot to put their middle name. You could write some JavaScript that says, hey, if they don't put a middle name, stop them right there, make them put in a middle name. That's fine. But check it on the server too. Double check it, always. All right, here's a little sample. Normal login. Person comes in, they got a username, they got a password, they put it in. A SQL Server sees, with our past example, select star from users where username equals Bob, and the password is equal to, a bunch of junk. Everything works just fine. Person logs in. Then we got the malicious login. Person comes up, puts in password Bob, puts in username Bob, and then password. Single quote, union, select star from users where admin equals 1, dash, dash. Now let's see what's happened here. the single quote, if we go back to the previous, you'll see that what we're trying to do is make it so that right where the password comes in, and if you go all the way back here, you'll see I have a single quote right after password. So what I'm saying is, close the quote. So make the SQL Server think that I just gave it the password, and the password was nothing. It was blank. And then here's some more SQL for you. And more SQL is union that with a select star from users where admin is equal to 1. Very simplistic example. Usually it's a little more complicated than this, but this should get the point across of how this is done. The dash dash at the end is a comment operator. Can anybody guess why that's there? Because, yeah, we got another quote, right? We got the quote that's in the code. We got to get rid of that, because we don't. What's going to happen is, if I got that quote hanging out on the end, the SQL Server is going to choke on it. So I have to get rid of that. I have to clean up. I've injected. I already closed the quote way back when, and now I've got to kind of comment that piece out. All right, and this, this is just a little sample here where somebody does a little search and they get some information back. This is kind of the, here's how you once inside the application might also perform an exploit. What's important about this is you kind of get a feel for a while, and I know David Litchfield, I think, is doing a similar presentation on where he's going to show how to get a feel for what the code is like just using these techniques. So he's kind of infer what's behind the scenes just by playing with input here. And that's kind of what I want you to get the feel of here. What's a soft target? A soft target is usually a search, some type of search field where you put in a name and then you get some results. And why do I say a soft target? It's pretty darn easy looking at this to know what's going on behind the scenes, right? I mean, what better use for a where criterion than somebody putting in a search criterion, right? That's where the where is going to, that's what's going to be there. You can picture it in your mind. Select last name, first name, email from some table where last name equals Andrews, right? Makes sense. And this is the kind of thing that he's probably going to have in his presentation. Where do you infer this kind of stuff? I find that search fields, any type of search information, is really the place to go. There's a lot that you can do here. Not the very least of which is that you can see exactly how many fields were returned, which is really good information. It'll save you a lot of time. Malicious usage, okay? We come in, we do something similar to what we did the last time, right? We close the quote. We use a union statement. We use select. I just put a couple of blank fields. I'm not really interested in pulling too much else at this time. And the last thing I may want to pull out is the version of the SQL Server, which, of course, really coughs up a lot of information. SQL Server version is great, but it tells you what version of the operating system is running and the service pack that's been applied, which is pretty nice information to have as well. I'm using union statements, and this is just an example of the things that you can do. I like to union because the union kind of lets me get immediate feedback on what I'm doing. If I don't use a union and I use some other method, think about it. Any other SQL can go here. So, I mean, if you really wanted to do something and attempt an XP command shell or something like that, you could always attempt that here. It's just, you might not get immediate feedback that your commands are actually getting through, which is why I like to use the union for the setup, for me to immediately get feedback from the SQL Server to know that I've done something malicious. All right, and what are the problems? The problems with both of them really start off with poor input validation. Nobody bothered to look at what I was passing in. Some of the stuff is simple, right? If you're going to have a user ID or something that you're passing, if your user ID is an integer, it's not that hard to check and see that somebody entered an integer, right? And there's a function for that, is numeric at VB. It's very simple to say, did they put in a number? And for that kind of stuff, it's simple. It becomes a little more complicated when they're putting in strings, but there's still things that you can do. Secrets in ASP code, poorly typed ASP in SQL Server, not checking data types, and security context too high for needed functionality. Exactly. Going back to that first screen, and we were doing our access as SA. It's just lame brain to do in the beginning. There's no reason for people to be using an application as SA, ever. Ever. I can't think of a single one. And if anybody can, just let me know. All right, tricks attackers use. Did I skip one? No. Tricks attackers use. Union statements to append data ripped from other SQL. The double hyphen comment, indicator to block out the rest of the intended SQL. Try a single quote. That's usually the way I'll feel out poor validation is the old single quote. If you can do the single quote, it's important for you to be able to quote out. So if you put it in and just hit enter, and the application comes back with some ODBC error, it probably just received 3 consecutive single quotes. And it didn't like it, and it choked on it, which tells me that somebody wasn't validating the input to begin with. I was able to put in a single quote. So it's just a quick way to sniff them out. Exec master XP command shell, and then pinging yourself, right? Or pinging someplace where you can see that the ping went through. Unless there's good egress filtering at the SQL server, and that ping, that ICMP packet makes it out, makes it to your firewall or whatever that's sending you alerts that it's being pinged, you know, it's a good sign that your code has been executed on the server if you don't have any other way to get some feedback. Select name from sysobjects where type equals you. Obviously, what this will dump out is all of the user-defined tables that are in that database. So in that previous example where I had 2 blank fields, why not go in there and select out all of the tables that are in this database while I'm at it? And this will give me some more targets, right? There's probably a table in there if it's an e-commerce application called user info or heaven forbid credit card info. Tells you right where to go. Insert table name, exec, SP, whatever, good way to see the output of store procedures. Yes, here's the command. I mean, this is just kind of, once you really start getting into SQL, you start to learn all these little tricks. Like here's, with this trick, you can basically say, take a table and insert all of the output that comes from running this store procedure. And in this case, it's, maybe XP command shell or something. It can be anything. It will take that output and just shove it right into that table. So if you can't get the feedback on a page, maybe you can send the feedback into a table that you can read at some later point. And of course, we always talked about selecting version information. It's good information to have. Another one might be selecting suser _ sname. That should expose to you the context that you're running with, which would be good to know. If you do this and find out that the application is running at SA, it saves you some time. You already know where to go for. You can pretty much go for the throat at that point. More tricks. The new SQL variant data type. The problem that I used to have trying to pull information out of SQL Server from the front end was that when I was doing these union statements, based on the data types that were in place, you have to match those data types up. So if I'm selecting an integer, and a varchar, I need to union that with an integer, and a varchar. And if I don't, I get an error. What? Well, now we've got the SQL variant data type. Thank goodness. It saves so much time. What you can do here is basically just convert whatever it is that you want, whatever it is that you're pulling in your second union statement into a varchar, and SQL Server will happily match up those data types for you. So it kind of removes that whole problem. And I think I did a little sample here where I showed a before and kind of the trial and error things I had to do to figure out the data types. And then I did afterwards where I basically just take everything that I want to select from in my exploit SQL and just convert it all to SQL variants. And no problem. Everything comes out great. That used to take a lot of time, especially you can imagine the permutations you had to go through where you were selecting 10 different fields from the SQL Server and you didn't know the types, right? How many times you had to try this over and over and over again to try to sniff out the data type. It saves so much time. All right, some solutions for input validation. A simple one. This one's kind of cheesy, but it works to a certain extent. I mean, it raises the bar. And that is to just replace the single quote with the double quote. This happens in a lot of places. You'll see a lot of applications do this. Largely effective for a lot of things. If you're checking for the right data type for integer input and for numeric input, and then you're using your you're using this to stop the varchar, the closing quotes basically, and keeping people from quoting out of their input, this is very effective. Not 100% effective, but very effective. There's also the regular expressions, which are also very nice. And in fact, in the securing the checklist for IIS-5, this is in here, except for the my regex global equals true line, which is not in the IIS document. If anybody's here from Microsoft, please go to them and ask them why that line's not there, because without the line, it basically just goes across, finds the first violation, and doesn't process the rest of the string. All right, and this is just a little example quickly of why it's not 100% effective. You know, in the case where you have some type of input that's not going to be textual, you're going to continue to have problems because it's not strongly typed. We have to check for the type. Input validation on stored procedures. Stored procedures can be very effective. And the first time people will ask about this input validation stuff, the first thing you'll hear from people is, got to use stored procedures. They're the solution. They will solve all the problems. Just start using store procs. Everything will be great. And the reason, of course, you know, basically SQL Server is going to precompile that plan, and it's going to say, I just want these two parameters, and these are the two parameters that you're going to put in, and that's all that's going to happen. If you were to say SP underscore login space, you know, single quote, username, quote, comma, quote, and then start putting some, you know, exploit code in. If you just put that inside those quotes, you know, everything's great. But we come to the same old problem, and that problem is that people poorly implement the stored procedures. Why? They use string building again, right? So they'll just sit there and they'll say cont execute, and they'll start building a string. And they'll say, okay, SP login, here's my username, here's my password. What's wrong with that? What's wrong with it is it's the same problem. If you look down at the password, if I inject my single quote, what happens? I just quote out of my store procedure command, and I can issue more code. SQL Server doesn't care that that first command was a store procedure and not a select statement. It's just more code for it to go through. Does that make sense for everybody? These are better implementations of stored procedures. If you've written good stored procs and you want a better way to implement them, this is the way. I heard somebody say to me the other day that their developers don't like to use this command object. They say that's the old way to access SQL Server. The old way. It's still the way that's recommended in most places. I personally like it because it's fairly strongly typed. You define exactly what the data type is. You tell it exactly what the parameters are, and ADO takes care of the rest for you. It makes sure that the SQL Server doesn't get more SQL. It knows what the SQL command is. It knows what the parameters are, and it takes care of things for you. It doesn't let people chain the commands and batch up SQL. Also, this is another nice method for the lazy people out there. If you don't like to go through all of that 15 lines of code, this will do the same thing. When you actually create a connection object, you can expose store procedures as methods of the connection object. So once I create a connection object there, con, I can just expose the login as a method. I provide it with the two parameters, which of course have been properly validated, I hope, somewhere. And then at the very end, if there's a record set, this is optional, you can actually just put a record, RS, and that has to be a record set type. But it will return the record set in that parameter. So if you guys really lazy programmers out there, they love this one. The main problem with it is that it doesn't accept output parameters. If you have output parameters, they won't pass the information back. Also, SP execute SQL. How am I doing on time, by the way? Am I doing bad? I gotta go pick up the pace. SP execute SQL is a way to enforce safe, strongly typed ad hoc SQL code. I highly recommend that if you don't know how to use this command, that you just after this take the time to go books online, do a little reading on it, and just learn how you can use this. There are people that insist that they have to do SQL access. Not everybody is willing to accept the, I got to write a store procedure for every bit of access. For some applications, that's a whole lot of store procedures, and they don't want to manage it. If they still have to use, and they just for some reason have to use ad hoc access, I highly recommend you take the time to use SP execute SQL. What's good about it, obviously, if you take a close look here, it's strongly typed. You're telling it what the parameters are, and the parameters, you type them, so people can't be putting invalid data types inside of those fields. Also, as a bonus, SQL Server can identify which piece of this is the SQL command, obviously the first piece, and which part of the parameters, so that if you execute another execute SQL behind this with different parameters, SQL Server is more likely to reuse the query plan. So you actually might get a performance benefit from doing it this way. When was the last time that you implemented something in security that improved performance? Discipline. Make sure developers adhere to standards, develop a methodology. I can't beat this over people's heads enough. This sounds like boring stuff, right? Policy development and writing documents to tell people what to do and they have to follow these rules. It sounds boring, but this is so important that people do this, that developers have to adhere to a set of standards and they're held accountable when they don't adhere to these standards. There was an issue that came up yesterday about developers on production servers. I felt in my heart, developers should never be on production systems, period. Much less, debug rights and all that stuff, just so they could trace, being able to trace an application running on a production server. You don't trace applications on production servers, I hope. Please, no. So this certainly should not be having any type of special access to any type of production servers. Consistent database access and developer education. This just means whatever you choose to do, be consistent about it so that you know what's going on everywhere. You don't want to have one application using SQL Server this way, one using it this way, and one using it this way, and then you really don't know what's going on. Develop a plan and follow it and be consistent with it. Encourage reusable security components. What I mean mostly here is reuse COM components that allow database access. I can't say enough, I don't like to see database access in script, period, anyway. I would prefer if everybody wrapped up everything they do as far as database access in some other type of code that I can centralize and control. Because otherwise, I can never, if there's a change in the way I want to do some database access, I have to make it all over the place. And it's nice to have it nice and centralized. You can say, hey, if you want to be able to access a database, you invoke this component, and you call this method, and you do the database access this way. Code review, very important. You got to have somebody looking over somebody's shoulder. You don't want to wait until the whole thing is done to have to go back and review it and kick everybody in the pants. Everybody should be programming in teams, partners, looking over their shoulders, making sure they're doing the right thing. This should be put in your QA test plans. Test plans should check for these things. The single quote stuff, all of these things we're talking about, QA people should be doing this. You shouldn't wait for somebody to try to do this on a finished application that's already been put out in the web. And in code, with intruder's mindset, always be thinking about the next layer every time you're coding an application. Best practices, use principle of least privilege. Like I said, local system, who needs it? You don't have to run with that, and don't. Why should a user be a DBO? Happens all the time, right? The application works all of a sudden when you make somebody a DBO. Don't do this, please. Take the time to whatever account you use, make sure it has the absolute minimum amount of rights to get the job done, period. Take the time to properly implement trusted security. Take the time, really. It'll save you a lot of pain later, pain and anguish. The problem that I run into with using standard security model is that no matter what you do, there's a secret somewhere. It might be in the registry, it might be in the code, it might be in global ASA, it might be wherever. It's there. If you can use trusted security model, you know where it is. It's in the SAM. And if they get access to that, you got bigger problems. Just like everybody, I think that was the Scott Culp, security axiom number 4 or whatever, right? Same thing. Consider dropping certain procedures in the interest of security. This is another one of those things. It's like dropping services in the NT. If you don't need it, why do you have it? Why is XP Command Shell sitting in your SQL Server if you never use the darn thing? Take the time to look at the store procedures that people have access to or exist on the machine at all, and then evaluate whether or not they need to be there. Like I said, writing reusable code is important. That's the DLLs. Perform ad hoc queries only through SP Execute SQL. Use stored procedures whenever possible, but avoid string building. Try not to use that string building technique where people are just building a string that's going to implement that stored procedure. It's very bad. Try to, whatever you do, make sure that the SQL Server knows exactly what part of the query is query and what part of the query is parameters. Evaluate third-party code and applications with great scrutiny. Maybe you won't have access to the code. You probably won't. But at least take the time to do some of these things to what they're trying to sell you. You wouldn't believe what software has these problems. I mean, I can't say what software has these problems, but trust me, this is a pervasive problem, and I'm surprised, frankly, that it hasn't become a bigger issue up to now. You know, we do hear about, you know, these web hacks, credit cards are being stolen. We don't always find out the details, but I think in a lot of cases, these are the techniques. And use SSL or IPsec to encrypt traffic on suspect subnets. Just goes without saying. If you can't trust what's going across the wire, do what you can to encrypt it. The intrusion detection stuff, I just wanted to mention this again. If you feel like you want to give it a shot and try to monitor the SQL Server activity, I've got some scripts for setting up some of this stuff if anybody's interested. You know, it is interesting to look at. Like I said, if you're going to go down that road and start auditing and start doing this kind of stuff and doing intrusion detection, please have somebody look at it, because otherwise you don't even want to head down that road. This is something that really hasn't been done yet. I'm just waiting for it. Somebody will think of it, some type of capability like a tripwire for SQL Server. The capability to take a look at your entire application and then know if any one thing has changed about it. I think it'd be very easy to do. I don't think anybody's just taking the time to do it. I just mentioned here briefly, maybe somebody here will go out of their way to just write something very quickly. Who knows, I may get bored one day myself, but there's plenty of SQL demo functions that will allow you to go in and automatically script out a SQL Server completely. You could use it to then go back and compare your SQL Server scripts today with what they were yesterday and make sure that none of the code has changed. Not the data, the code. And a poor practices example, I don't want to beat on Microsoft too much. There is Application Center Server coming out. It's a fine product, I've seen it. I just want to make sure that everybody knows that these kinds of problems are pervasive. Everybody does them, and Microsoft does them as well. I'm not saying that I've found an exploit in Application Center, but I will say that the accounts that they use to access their MSDE, it's under a different name now, but when they actually accessing SQL Server for the purposes of Application Center, they're doing it with accounts that have full system administration rights. So, something to keep an eye on. Am I out of time? Doing okay? All right. Web services. Just wanted to put this as the last couple of slides here. In Microsoft.net, you're going to see some new things. Web services is something that they're pushing pretty heavy. The idea that you would have the capability to make remote procedure calls across the internet via SOAP to other places, other servers, other businesses. And it is an interesting idea. I think it's pretty cool, actually, if anybody's ever played around with SOAP. It's probably been waiting on somebody to really get behind all this and start to push it, and Microsoft is really doing it. But I would imagine that a large deal of what goes into web services will be front-end to database applications. So you can imagine this web service behind the scenes is really just doing some type of SQL that somebody's going to be able to just put parameters into. So it's like, you know, it's like a nice automated front end for doing this type of attack. So if you're going to be coding web services, please take these same techniques into account. I mentioned UDDI just basically here. I find it interesting. That's the Universal Discovery and Description and Integration concept that's kind of being pushed forth by Microsoft, Ariba, and IBM. I don't know how those three got together, and I bet those were some interesting meetings. But they've gotten together to put together this kind of they're going to put together a kind of a service, somewhat like the DNS, where you can go out on the internet and make a query like, show me all of the people in Atlanta, Georgia that will take some type of service or some type of product and convert it to something else. I mean, it could be any type of business process you can imagine. Just show me all of the shippers in Atlanta, Georgia that ship the so-and-so, but also offers this web service that does this, that, and the other. So it gives you the idea that it's along the way somewhere, you'll be able to target businesses that offer web services, certain types of web services, and maybe at some point have the ability to automatically or automate an attack process. Like I said, UDDI is just forming. It's not really here yet 100%, but keep an eye on it, and let's just make sure it doesn't turn into something evil. The .NET framework includes input validation, encryption, and session management functions. All this stuff is great. Developers have been waiting on this forever. Now you don't have everybody and their mom coming out with their own schemes for doing all this stuff. Microsoft's kind of leading the charge here with, hey, we're gonna write this stuff for you. Use our framework, and you'll be okay. The encryption will be good. The session management will be good. And it's a great idea, and it is a good thing. But let's just make sure that it's good. So when it comes out, we ought to be pushing it, and we ought to be making sure that their implementations are good, because if the framework is bad, then rather than that one site's installation being exploitable by a problem with the framework, everybody's infrastructure could be affected by a single problem in the framework. Here are some reference links, places I'd recommend you take a look at if you're interested in SQL Server security. And some recommended reading, some of my favorite stuff here. Obviously, what got me started on all of this really was the Frack magazine article by Rainforest Puffy a few years ago. Got me thinking about some of this stuff, and that's basically where it's come from. That's where it all started. All right, are there any questions? Sure.
The assumption for integrated security is that the web server has to be part of a member of the AD.
Pardon?
The assumption for using integrated SQL security is that your web servers have to be a member of a domain or active directory to use integrated security.
No, when I'm talking about the Active Directory, I'm talking about the delegation is what's required. If you're going to use delegation, you have to use Active Directory.
No, I'm talking about instead of using SA passwords, using integrated Microsoft authentication. If your web server, let's say, working by itself and has to talk to a SQL database,
right?
Using Windows Authentication, how are you going to do it if it's not a member of that domain or that?
Right. The user account that's being impersonated, right, on an IIS server would need to be somebody that the SQL server can see, right? So if it's a local account with a local iUser account on that web server, he's not going to be able to see it over here, right? So that's when you go in and you create a domain user account and use that as your anonymous user account that the SQL server can see and he can see. The other way that Microsoft recommends is that you use they basically have this account synchronization scheme where you create an account on the SQL server. You sync up the passwords. You've seen that document. Everybody has problems with that. Yes. Yes. Question? Read mail? I don't implement read mail at all in SQL Server. Yes, that's the safest way. I don't touch that at all there.
I haven't looked at 2000. Do you know if any new? Basically the subnet mail would basically execute.
Well, just keep in mind, in order for that to work, you have to turn on this. You have to turn on the SQL mail, right? Right. So that's one of the reasons I don't turn it on, right? It's just another way for somebody to get their return data back to them once they start exploiting my SQL server.
Well, I definitely see utility there. With some type of mailbox system, first automated processing in an offline manner without delegating permissions necessarily.
Right.
But you can't. Clearly, one reason to do that is if you don't have user validation going on, but we should absolutely be able to validate the content.
Absolutely. Yes.
That happening in order to get inside of that.
No, they basically just punt on that, yeah. That's all. That's your job. Oh, I'm sorry, go ahead.
Yeah, you have mentioned a few times that it is local to put username and password in the script.
Right.
How do you overcome the problem that when you open a DSN, that you put the username and password there? How do you come about this problem?
How do I avoid putting the username and password in the connection string? I use a trusted connection. Yeah. Using trusted security, where I say the DSN is equal to this, trusted connection equals yes.
I'm going to use the password in the DSN already.
Well, in this case, we don't need the username or password. You know what I'm saying? It's already running with a security context. I'm going to use that context to attach to the SQL server. There's no more context needed. I don't need to become somebody else. I don't need a username password pair. I'm already a user. I'm the anonymous, web user, or I'm some other account that I've created for the SQL server, for the IIS server to be that the SQL server can see, right?
Force the user to log into your ISP. If you have ACLs on,
Okay. All right. Any more questions? All right. Thanks. I appreciate it.